I welcome all of you to this interesting course that is an introduction to rocket propulsion. Let us start this lecture with a thought process from Hermann Oberth, who says that rockets can be built so powerful that they would be capable of carrying a man afloat, and this statement was given by him around 1923. It was really very difficult to imagine to have a rocket that can float a man, but today we have achieved phenomenal success in the rocket propulsion, and a question might be coming into your mind: what do you mean by propulsion and how it can be helpful? So, when you talk about the rocket engine, it is basically a kind of engine that can be used for propelling a space or terrestrial vehicle. In other words, it should produce certain amount of thrust such that a vehicle can be moved in space and even beyond the nearby of the earth into the deep space. So, then question arises, what do you mean by propulsion? Propulsion, if you look at it, is basically derived from a Latin word known as propellere, that is, can be divided into two words. One is pro, means to forward or the backward, and propellere means to basically drive or push something. In other words, you can say the propulsion is a process by which one can really drive a vehicle in certain direction, either the forward or the backward. Propulsion need not to be only associated with the rocket. It can be also used for an aircraft or a ship or any other vehicle by which you can have travel. What is the basic principle of rocket propulsion? In other words, you can think of using basically laws of motion, because you are dealing with a device which will make the vehicle to move forward, and this is basically governed by the Newton's laws of motion. And all of us are having not only with the experience with the motion, laws of motion, but also with how it is. And we are all aware about the three Newton's laws of motion, and of course, one is about inertia, which states that as long as a body remains in motion or in static, it will maintain its state. In other words, if a vehicle is moving, it will be moving unless otherwise it is having a resistance force to stop it, or a force which is opposite direction. And if a body is in one place or a state, it will be also there unless otherwise it is acted upon a force that makes it to move. And the other two laws of motion, which will be more important for rocket propulsion and propulsion, as say, is basically momentum conservation law, that we know that whenever there will be a change of momentum of any mass or a vehicle or anything, then there will be that must be acted upon by a force, and which is basically overcoming the resistance forces which will try to keep that body in its equilibrium position. And that is the second law of motion, Newton's second law of motion. that is, a force is equal to mass into acceleration. And there is another law, which is the third laws of motion. We state that every force is an equal and opposite reaction. In other words, every action has an equal but opposite reaction. And let us look at an example to illustrate this laws of motion, and we can say that this is a spherical balloon. Of course, balloon can be of any shape, and which contains air such that it is in inflated condition with a stem which is closed. Under this condition, the forces are acting in all direction on the skin of the balloon, and also it is in equilibrium. And if I will open this stem and allow the air to move, what will happen? That means certain amount of air which is under pressure in this elastic skin of the balloon, which will try to move, push, and such a way that it will be some mass will be passing through a certain velocity out of this stem. And of course, there will be a change in momentum from this balloon to the outside atmosphere. As a result, there will be flow of fluid which will be taking place, and there will be an equal and opposite force which will be acting. And of course, other side the forces will be cancelling each other and the other force, that this movement of the fluid inside the balloon through the stem is known as action, and the opposite to that is reaction, because it wants to remain in equilibrium so that it will be balanced. But however, in this case the force is acting basically on the balloon that makes it to move, because when you talk about the Newton's third law of motion, that every action is an equal but opposite reaction, that basically it is acting, the change in momentum will be acting on the fluid, where this change in momentum of the fluid will be giving a force in the opposite direction on the balloon. Therefore, that is making the balloon to move, and that is the heart of rocketry, as the action of rocket engine produces the forward motion of the rocket. And of course, this is with the balloon what it will be, because it cannot really supply the fluid for infinitely, because the fluid stored in this inflated balloon will be exhausted out. But however, when talk about this rocket engine, we need to look at how we can provide the high pressure and temperature gas to be passed through a nozzle, which is shown here. This is basically a nozzle, such that it will be producing the thrust at least for certain amount of time. So, if you look at the when this fuel and oxidizer, which is not shown here in this diagram, will be burnt, and then it will be producing high temperature gas and high pressure gas, and which will be expanded through this CD nozzle. This is basically conversion diversion nozzle, and as a result there will be change in momentum of the fluid, and it will be giving a opposite direction, a force that we call thrust, and that makes the rocket to move. And this is the heart, or this third law of motion is the heart of rocketry, as the action of the rocket engine produce a force that we call it as a thrust. So, therefore, it is very important that the Newton's law, third law of motion, and also the Newton's second law of motions are very important for providing a thrust to the vehicle, by which we really get the rocket to move. And as I told earlier, that the fuel and oxidizer get burnt in the combustion chamber, which is forcefully ejected through a CD nozzle, conversion diversion nozzle. As a result, the thrust that is a reaction, as I told earlier, which is equal to and opposite to the action that is acted upon the vehicle. So, let us look at what are a typical rocket engine which I have shown here, and in this case certain amount of the mass of the propellant, which is at high pressure and temperature, will be passing through the nozzle and through the exhaust gas, which is motion shown in here. And it is of course vertically the weight of the vehicle is acting upon here, and there is the reaction force, or we can call it as a thrust also, that is acting up. That means the three forces are acting on this vehicle. And question arises, what are the factors that affect the acceleration of a rocket engine? Obviously, these three forces will make the rocket to accelerate, provided that thrust is much greater than the total force exerted due to weight of the vehicle, and another forces will be there is also the resistances, the friction or the drag forces, right. There will be force due to drag. So, if you look at the acceleration gained by the rocket engine will depends on three factors. One is the exhaust velocity with which the burned propellant is passing through the nozzle, and the rate at which the exhaust is ejected through the nozzle, and the mass or the weight of the rocket. So, this balance which will be really making this rocket to accelerate. So, this is about the basic principle of the rocket propulsion, what you can think of, and that is the that is the main things what we need to really worry about, and we will be discussing about various aspects of the how we can really classify the propulsive devices. Though propulsive devices can be broadly divided into two categories, one is air breathing engine, other is non-air breathing engine. Air breathing engine, as the name indicates, that it will be basically breathing the air. However, the fuel will be carried by the propulsive device, and non-air breathing engine is one in which both the fuel and oxidizer will be carried out. And this air breathing engine, all of you know, the example could be your aircraft propulsive device or the ship propulsive device. And this air breathing engine again broadly can be classified into two categories. One is the constant volume engine, and other is the constant pressure engine. The constant volume engine is basically one in which the combustion will be taking place when the volume remaining almost constant, and in the constant pressure engine the combustion between the fuel and oxidizer will be taking place when the pressure will be remaining almost constant. The constant volume engine can be divided again into two categories. One is your piston engine, that all of you are aware. This piston engine is being used profusely for automobile engines and other small power plants, and it is also used for the small aircraft engines. And there is another engine which is not being used very much, but however it is coming up well, is the Wankel engine. And this piston engine is basically a piston cylinder arrangement in which the combustion will be taking place, and all of you might be aware about that. But Wankel engine is one in which it is a combustion will be taking place in a rotary devices. The difference between piston engine is basically the combustion will be taking place in a reciprocating engine. In other words, in the piston engine there will be piston which will be moving up and down from top dead center to bottom dead center, and which is also known as the reciprocating engine. However, in the Wankel engine it will be moving all the time, and it will be taking the fuel and oxidizer, it will be compressing, it will be then combustion will be taking place, and then it will be exhausted out, producing certain amount of power. The same processes will be occurring in the piston engine, but in a reciprocating device, which will be converted this reciprocating motion into rotary motion. As a result, this piston engine is little bulky, but whereas the Wankel engine is a very compact engine. However, it is not being used very much as it under the developmental stages. And constant pressure engine is which one is being used very much for the aerospace application, and of course, you will be knowing these are mostly a jet engine is also known as, because you produce a jet and with the help of a nozzle, and then that will produce the thrust. And the engine which is being very much used, all of you will be aware that is a turbojet engine. Turbojet engine, that will be turbofan engine, turboprop, and sometimes it is also called as a turboshaft engine. Whenever you use a propeller to produce the thrust, that is known as turboprop engine, and when you need the power without any really propulsion kind of thing, we call it a turboshaft engine. And turbojet engine, which is being used for your fighter aircraft and other big passenger aircraft. Turbofan engine also used for passenger aircraft, and nowadays turbofan is basically workhorse for the passenger aircraft, and turboprop and turboshaft are being used for helicopter engine, even for a smaller aircraft. Beside this, we are having another kind of engine which is known as ramjet, and that is also known as scramjet engine. Ramjet engine is basically where you will be using the ramming power such that you do not have compressor in it. Ramjet is basically used for missile applications, and the scramjet engine where the combustion will be taking place on the supersonic speed, such that this is known as supersonic ramjet engines, and which will not, and these are all air breathing engine. It cannot really operate beyond maybe 30 to 40 kilometer of altitude from the earth. And the non-air breathing engine can be divided into three categories. One is the Photon engines, other is rocket and solar cell. And if you look at Photon engine, is basically a engine that generate the thrust from the momentum of photons. And as you know that photon is generated due to various ways. It can be generated due to radiative pressure from the emissions, and this is a very advanced engine. It is considered to be the next generation propulsion device by which one can have interstellar flight in future. And in this case, of course, various power can be, energy can be used, that is your nuclear energy can be utilized to produce the photons so that it can be propelled. And it is beside this, people are thinking of using the photonic laser thrusters, and also the beam laser can be used for producing the photonic or photon rockets, such that you can have a interplanetary flight. And solar cell is a method of propelling a spacecraft by using the radiation pressure exerted by the sunlight. Therefore, it is a solar cell. It is similar to that earlier days people are using ship that is being sailed due to the wind speed. There will be change in the wind momentum when you put some kind of a sail on the boat or the ship, such that it will move. In the similar way, in this case the solar cell will be using, such that photons will be bombarding on a kind of a solar panel or a panel, such that it will be moving. And it is also considered to be the next generation propulsive device for interstellar flights or the interplanet flight kind of things. And this is considered to be very cheap, and also it can be operated for a longer period of time. And beside this, people are thinking of using the laser power and also the nuclear power to operate, and of course, it is in the infancy stage. But this course will be mostly dealing with the rockets, and these rocket engines can be broadly divided into two categories. One is your chemical rocket engine, and other is your non-chemical rocket engine. And chemical rocket engine, based on the type of propellant what we use, we call it basically the solid propellant rocket engine and liquid propellant. And there is a combination of both, what we call is hybrid propellant rocket engine. But we will be discussing more about it later on, because this course is basically more focused on the chemical rocket engine. And non-chemical rocket engine can be again broadly divided into three categories based on the kind of energy being used. One is of course the solar, other is electrical, and the third is basically the nuclear rocket engine. We will be not discussing much about it. However, in the end of it, we will be discussing about the nuclear engine in more detail. And let us look at what we will be covering in this course. The course content will be like this. As I told, we are currently basically introducing about the rocket engines. Beside this, we have already seen the types of rocket engines and application of rockets that we will be seeing, and then we will be looking at aerothermodynamics of rocket engines. Later on, we will be looking at the ideal rocket engine, thrust equation, and rocket engine parameters that affect the performance of the rocket engine, and then we will be moving into the rocket engine nozzles. Then we will be looking at the space flight performances, and of course, this will be the half of the course roughly, and then later on we will moving into the three rocket engine, that is solid propellant rocket engines, liquid propellant rocket engine, and hybrid propellant rocket engine, which we will be discussing in detail. And in the end, I will be trying to devote maybe 1 or 2 lectures on the non-chemical rocket engines. So, these will constitute your courses, entire course, and I would suggest that you can use the book Fundamental of Rocket Propulsion by D.P. Mishra, that is myself, as a textbook. Beside this, you can refer the other books like Mechanics and Thermodynamics of Propulsion by P.Z. Hill and C. Peterson, Rocket Propulsion Elements, which is the very exhaustive book, that is by Sutton G.P. and Biblarch O. You can refer this book, and this is a very old book which is maybe available in some place, that is Rocket Propulsion by Barare M, Jaumote A and Vanderkerkhoff J. And of course, you may need little bit combustion. So, I would suggest you can look at Fundamental of Combustion by D.P. Mishra, and which is available in India. And these are the things we would like to really discuss in the next lecture. We will be discussing about the various aspects of the rocket propulsions and how we will be looking at various aspects of the introduction about applications of the rocket engine. Thank you very much for your kind attention.